In this video, I provide a practical guide to finding the right amplifier for your hi-fi system. But you may ask, hey, shouldn't all amplifiers sound the same? No. But why not? Why are all amplifiers not the same? All an amplifier does is amplify the line level signal to speaker level, right? Well, while all amplifiers amplify, the way they handle or maintain signal integrity, distortion, and load interaction throughout the amplification process makes each design a bit unique. In other words, from a high fidelity perspective, amplifiers are not all the same because amplification is not a simple or straightforward process. The way an amplifier handles signal amplification, distortion, noise, impedance matching, and power delivery has a significant impact on the overall sound quality. Selecting the right amplifier for a set of speakers is essential for achieving high fidelity sound reproduction. The amplifier's job is to power the speakers without distortion while preserving the details, the dynamics, and the tonal balance of the music. However, not all amplifiers are a perfect match for all speakers. Understanding key technical specifications such as power output, impedance matching, damping factor, and amplifier class can help ensure synergy between the components for the best possible listening experience. I'm going to list a few factors. First factor in this guide is matching power output to the speaker needs. One of the first considerations when selecting an amplifier is its power output, which is measured in watts per channel. The ideal power range depends on speaker sensitivity, which is measured in decibels per watt at 1 meter. This tells us how efficiently a speaker consumes power and converts the electrical energy from the amplifier into sound. Higher sensitivity, I would say about 90 dB and above, those speakers require less power for loud playback. Lower sensitivity, say below 87 dB, needs more power for the same volume. Listening environment and volume needs. Most small rooms and moderate listening levels require about 20 to 50 watts per channel, and that may be sufficient. Large rooms or loud playback, I'd say about 100 watts per channel or more might be necessary. Large rooms and loud playback definitely recommend more than 100 watts per channel, depending on speaker sensitivity, of course. One important aspect to keep in mind is headroom for dynamics. Music has quiet and loud passages, so having an amplifier with extra power helps deliver clean, undistorted peaks, especially in dynamically uncompressed recordings like some really good orchestral music or live performances. Coming to the second factor, impedance matching ensures efficient power transfer. Speakers and amplifiers have impedance ratings measured in ohms. Most home audio speakers are rated at 4 ohms, 6 ohms, and 8 ohms, and amplifiers are designed to handle certain impedance loads. If a speaker is rated at 8 ohms, it works with most amplifiers. 4 ohm speakers demand more current and require an amplifier capable of handling lower impedance loads without overheating or shutting down. So checking your amplifier specs helps. An amplifier rated at 100 watts into 8 ohms but 200 watts into 4 ohms indicates it's a well-designed high current amplifier for demanding loads. If an amplifier lacks a 4 ohm rating or has warnings about driving low impedance loads, it may struggle with power-hungry speakers. For example, a high current amplifier that doubles its output from 100 watts at 8 ohms to 200 watts at 4 ohms would be great choice for 4 ohm speakers. Third factor is the damping factor, controlling the speaker's motion. The damping factor is the amplifier's ability to control the movement of a speaker's driver, particularly the woofer. High damping factors above, say, 100 have tighter bass control and less overhang, ideal for precision in low frequencies. Lower damping factors below 50 ohms, the bass can sound a little loose or muddy, especially in large speaker woofers. For high fidelity sound, an amplifier with a damping factor of about 200 or more will provide better transient response and bass clarity. Fourth factor, and this one is a bit long and my favorite, amp topology. When selecting a high-end integrated amplifier, it is important to understand different amplifier topologies and how they affect sound quality, efficiency, and speaker compatibility. Here's a breakdown of most common amplifier classes. Class A, considered the most linear and distortion-free because the transistors are always conducting. Most of the experienced audiophiles would conclude that Class A amps produce a smooth, unfatiguing, warm, and natural sound with excellent mid-range and tonal purity. The Class A amps efficiency, not to be confused with speaker efficiency, is indeed very inefficient, only about 20 to 30%, generating a lot of heat, requires large power supplies and heavy heat sinks. It is best suited for those with high efficiency speakers or mid efficiency speakers in a small room and lower listening levels. One must also have sufficient ventilation, needless to say, due to the heat it generates. Some examples of Class A amplifiers are the Passlabs INT25, Accuface E800, or the Luxman L595A. Next up is Class AB, which is a balance of sound and efficiency, a mix of Class A for lower power and Class B for higher power. More efficient than Class A while keeping distortion relatively low. Good Class AB designs offer great dynamics, control, and detail with perhaps a smidge less warmth than Class A. They are more efficient, about 50 to 70%, and they run cooler than Class A. There's less heat dissipation, making it more practical for powerful amps. Best suited for those who want audiophile grade sound without extreme power waste. Works well with a variety of speaker sensitivities. Some examples includes Riga amplifiers like the Brio, Elex, Elicit, or the Yamaha AS integrated amps, the Macintosh MA352, or the Hagel 590. Next up is the Class D amplifier, which is a type of power amplifier that uses switching techniques to amplify an audio signal with high efficiency. Unlike traditional Class A or Class AB amplifiers, which operate in a linear fashion, Class D amplifiers rapidly switch their output transistors, fully on or fully off, significantly reducing power dissipation and heat generation. Modern high-end Class D amps sound clear, fast, and detailed, but some still prefer Class AB for a more organic, earthy tone signature. There are exceptions to this. I have owned a few Class D amps from Wired for Sound and Peachtree Audio that have that tonal warmth to their presentation. All depends on design execution. They are highly efficient, 80 to 90%, generates very little heat, compact and lightweight, often used in digital and streaming amplifiers. It's best suited for those looking for compact designs, energy efficiency, and high power output. They are great for subwoofers and power-hungry speakers needing that high damping factor. Some examples of Class D are the NAD M33, the Wired for Sound SDI series of amplifiers, and Peachtree Nova amplifiers. Next popular amplifier topology is Class G, adaptive voltage rails for high efficiency. Operates much like Class A at low power levels, but switches to higher voltage rails for high power demands. Reduced heat while maintaining Class A-like sound at lower volumes. Well-designed Class G amps offer dynamics, engaging sound with good detail and control. They are more efficient than Class AB, somewhere in the 70 to 80% range. Cooler operation, avoids constant high power consumption and heat dissipation of pure Class A designs. They're best suited for those who want Class A purity for quiet listening but dynamic performance at high levels. Works well with both efficient and demanding speakers. The superb sounding Arcam SA20 and SA30 are solid examples of Class G amplification. Here's a video card for you to check out a review of the Arcam SA20. Another amp topology is Class H, dynamic rail switching for even greater efficiency. The sound quality is similar to Class G but uses continuously variable voltage rails instead of stepped rails. Optimizes power usage, reducing distortion at high volumes. It retains the clean, detailed, and punchy sound with better efficiency. It's more efficient than Class G, 80 to 90%, less heat generation, can deliver high dynamic peaks without wasting energy. Best suited for home theaters and high output music systems in the professional arena. Examples are some pro audio amplifiers from QSC, though rarely this technology is found in audio grade integrated amps. I've used some pro amps from QSC with great success for powering my DIY subwoofer designs. They seem to control the subwoofer drivers really well for that taut and articulate bass. Last amp topology that I'd like to discuss with you today is the Class XD, a hybrid crossover-free AB design. I believe is created by Cambridge Audio. Operates like Class A at low levels but shifts its bias dynamically to eliminate crossover distortion. Sound quality is Class A-like warmth with power efficiency of Class AB. Efficiency is of course better than Class A, but a little below Class AB. The Cambridge Audio Edge A is the only example that comes to mind. So which type of amp should you choose? That isn't a straightforward answer. It depends on your preference and your setup situation. Finally, the most important factor in selecting your integrated amplifier is practicality and connectivity. An amplifier needs to integrate well with your audio system and serve your needs. Consider the number of analog inputs. Both RCA and XLR would be nice. RCA for standard sources like turntables with preamps, CD players, tape players. XLR for balanced connections. Also, consider seeking preamp outputs for connecting to subwoofers. I look out for XLR pre-outs as well, as my subwoofers have XLR inputs, and I find it very useful in eliminating noise-related hum when I have to run long cables for my subwoofers placed far apart. Also, with XLR connections, you typically have a plus 6 dB gain in signal. You may also need an amp with internal DACs that have digital inputs like optical coax or USB if using digital sources like streamers or your computer. The Peachtree Nova integrated amps, they have a superb built-in DAC, and so does the Arcam SA20, and I'm told the SA30 as well. Also, if you're in vinyl and not looking for an outboard phono stage, look for built-in phono stages. That's required for direct turntable connection. The Riga integrated amps have excellent built-in moving magnet phono stages. Do you need built-in streaming and wireless features? Some modern amplifiers include Bluetooth, Wi-Fi, or network streaming from lossless streaming providers like Qobuz or Tidal for high-fidelity source material. All in one box, and it is definitely a big convenience. I'm told that the Arcam SA30 is a wonderful sounding integrated amp with streaming capabilities. It's been discontinued, but I can't wait for their new integrated streaming amplifier, the SA45, to come out. Choosing the right amplifier for speakers is about more than just power. It's about ensuring proper impedance matching, sufficient damping control, and selecting an amplifier class that aligns with your sound preferences. Understanding these factors will help you create a system where the amplifier and speakers, and the room of course, all work together harmoniously, delivering clear, dynamic, and immersive sound. Here's a video of a power amp that you really need to know about. It's from Chord Electronics. It's a sleeper in the audiophile world, but used in many recording and mastering studios. It's been the hub of my reference systems for a while now. Tell me about your forever amps in the comments below.